Have you ever looked at a problem and just felt completely overwhelmed? Whether it's an engineering diagram, a piece of software, or even a math textbook, some challenges just seem impossibly complex. Well, that's what we're going to tackle today. We're going to unpack a universal toolkit for conquering that complexity by looking at three totally different fields to find one single powerful method. Okay, let's get into it.
So this is what complexity looks like on the page. On the left, you've got a formula from structural engineering. It's about how a beam resists bending. On the right, a double summation from a linear algebra textbook. And look, if your first thought is, whoa, what am I even looking at? Trust me, you are not alone. This is that feeling, right? Being hit with a problem at its most dense and intimidating.
And it's not just about weird symbols, is it? It's about entire systems. Over on the left, that's the super intricate 3D model for a 68-meter footbridge, and on the right, a digital publishing pipeline designed to turn thousands of pages of complex math textbooks into ebooks. One's built out of steel, the other out of code, but you can feel it, right? They've got the same DNA of just overwhelming detail.
So you're looking at all this stuff, and the big question just hangs there. Where do you even start? How do you go from feeling totally stuck to actually, making progress? Well, the answer is surprisingly simple, and it turns out it's the same whether you're building a bridge or a book.
All right, so the first principle, it's going to sound almost ridiculously simple. You don't start by trying to understand all that complexity. Nope. You start with the absolute simplest model you can possibly imagine. The experts don't just dive into the deep end. They find a shallow, manageable place to get their footing first.
Let's take that bridge. Before they ever got to that crazy 3D model, the engineers started right here, with a simple, solid beam that's fixed at both ends. It's so basic, you can literally look up how it behaves in a reference book. It's not realistic yet, and that's totally fine. That's not the goal. The goal is just to get a foothold, right? A solid, simple place to start building from. And you see the same idea in pure math, too. You've probably heard the story of the brilliant mathematician Carl Friedrich Gauss, right? When he was just a kid, his teacher told him to add up all the numbers from 1 to 100, probably just to keep him busy. But instead of starting that long, tedious task, he spotted a beautiful, simple pattern. 1 plus 100 is 101, 2 plus 99 is 101, and so on. He simplified the problem down to its essential logic. And guess what? It's the exact same logic for software. When the challenge was converting thousands of pages of custom code, the advice wasn't to start from a blank page. It was to start with a working template, a sample book, and then just build out from there, testing constantly. Start with something you know already works.
So that's the secret, right there. The first step to solving a really complex problem is to pretty much ignore most of it. Find one tiny, simple, solvable piece that gives you a solid place to stand.
Okay, so you've got your foothold. You've got your simple starting point. Now what? Well, you don't make a giant leap to the end. The next part is all about patience. You build, layer by layer, piece by piece. Let's go back to that bridge, because you can see this process play out perfectly. After that simple beam, the engineers add a rotational pin in the middle. Okay, next, they introduce the angled supports. Then they finally implement the actual truss elements. See what's happening? Each step adds a new layer of realism, a little more complexity, but it's all controlled. It's understandable as you build towards that final design. And it's the same layered approach with that ebook project. The creator didn't try to fix everything at once. He found one specific problem, these custom coding shortcuts, they're called macros, and he found a specialized tool to automate just that one thing. He built a pipeline of solutions where each tool was like another manageable layer on top of the last. And this really gets to the heart of it. You don't conquer a complex system in one big, heroic battle. You build it, carefully, deliberately, from simple parts until it starts to look like the real world you're trying to model. And here's where things get really cool. This whole methodical process, it doesn't just get you an answer at the end. It starts to reveal these deeper truths about what you're building, things you never, ever could have seen at the beginning. This is an absolutely perfect example. It was only after building the full 3D model that the engineers saw this. The model predicted that the arched legs of the bridge were so flimsy sideways that they would actually buckle and cross over each other. I mean, that's a catastrophic flaw, right? And it was totally invisible in all of the simpler 2D models. The complexity had to be built up before this hidden behavior revealed itself. Now, let's be real. This whole process isn't always some beautiful, elegant journey.
I love this quote from Michael Hartle, the guy who made the EPUB pipeline. He admits that getting the math equations to render perfectly was, in his words, excruciating. But the payoff was huge, a fully automated system that could do what major publishers couldn't. The triumph comes from mastering the complexity, not from avoiding it.
So you see, the model, it isn't just a tool to get you to the answer. The very act of building it, layer by painstaking layer, is what gives you this deep intuitive feel for the real system you're working with.
All right, we've seen this in action in engineering, in digital publishing, and even in pure math. So let's zoom out and put it all together. Let's build that clear, universal toolkit that you can use on, well, on any complex problem. Here it is, your toolkit. It's just 3 steps. Step 1, find a simple foothold. Ignore all the noise and start with a version of the problem you can actually solve. Step 2, build incrementally. Add 1 layer of complexity at a time, no giant leaps. And step 3, refine and discover. Use the model you've built to uncover those hidden behaviors and really deepen your understanding. And this whole toolkit really, it all boils down to one simple idea, summed up perfectly by Professor Stefan Huber in his math lectures. His teaching principle is KISS. Keep it simple and straightforward. I love that. Even when your final goal is incredibly complex, your starting point has to be simple. And you know, in the end, this is about so much more than just solving a technical problem. As the math notes suggest, this process helps us separate our logic from our emotion. That initial feeling of being overwhelmed, that feeling in your gut that says this is impossible, that's an emotional response. What this toolkit does is it gives you a logical path forward. It turns that scary, overwhelming feeling into a clear series of manageable, totally solvable steps.
So the next time you're staring down a problem that just feels impossibly huge, don't try to swallow it whole. Instead, just ask yourself this one simple question. What complex problem will you simplify first?